We've been talking about the two worldviews, and in our last session we talked about the two kinds of science, observational science and historical science. Both are important, but they have limitations. Everything that we have discussed so far has a profound impact on our next topic, radiometric dating, which is estimating the age of rocks based on the elements found inside them. We're going to watch a 3.5-minute video, and then we're going to come back. It's lighthearted and informative, so don't let the topic scare you away. I have provided a link in the description box to take you to our video today. If there's a problem, you're looking for a video on YouTube, in the search box, type in "Check this out, radiometric dating," and you should see a thumbnail that looks like the DVD cover off to the right. Watch the video, come back, and if you lose your place in my video, just fast forward until you see this image. Okay, since you're back, I'm going to assume that you've watched the video and now you're ready to move on to the discussion. Before we get started, I would like to draw your attention to these two words, assume and assumption. When you assume, or when you make an assumption, is to believe, take for granted, or accept something as true without proof. Keeping these two words in mind, let's do our first question. Name one assumption some scientists make when using radiometric dating. One assumption that is made during radiometric dating is that the decay rate, that's the speed in which the elements break down and leave the rock, is always the same. We interrupt this presentation for an important announcement. Observational Science has discovered that hot lava changes radiometric dating test results. It doesn't take much heat to melt lead, which means the elements inside escape faster. But uranium takes a lot of heat to melt it down, which means the elements inside escape slower. Congratulations! Your radiometric dating test results are messed up. We now return you to your regularly scheduled program. In the example of the hourglass, name one or two things the video mentioned that would change our time calculations. In the example of the hourglass, these were given. Was there any sand at the bottom of the hourglass when it was turned over? Has any sand been added or removed from the hourglass? And has the sand been falling at a constant rate? These three examples represent forces in nature which can change the results of our radiometric test. Which type of science is used to accurately determine the age of rocks? Observational science or historical science? This was a trick question. If you said you need both observational science and historical science, you're correct in that. But the word accurately cannot be used. Going back to the example of the hourglass, since we haven't observed the initial conditions and we haven't been watching the sand the whole time, we don't know if any changes have been made to the hourglass, so we must make assumptions. Since we cannot observe the process that made existing rocks from start to finish, do you think that radiometric dating is a reliable method of figuring the age of rocks? With all the assumptions involved, radiometric dating is not a reliable method for determining the age of rocks. We interrupt this presentation for another important announcement. There are over 40 kinds of tests to determine the age of rocks, but each one will give you a different answer. This means one test will tell you thousands of years and another test will tell you millions of years in the same rock layer. Oh dear, Something isn't right. We now return you to your regularly scheduled program. A scientist can observe and study the decay rate of the elements inside the rock using observational science. But a good scientist cannot use his test results as proof that a rock is millions of years old. As of the year 2015, observational science has discovered at least 4 elements that do not have a consistent rate of decay. These elements are cesium-137, cobalt-60, silicon-32, and radium-226. The rate at which these elements break down speeds up and slows down during the subtle changes as Earth orbits the Sun. Scientists find this baffling and they're conducting further research. My point in bringing this up is that if the Earth's orbit around the Sun can affect the decay rate of our elements, then what other forces in nature are changing the test results of our radiometric dating? Remember that you are surrounded by the worldview of there is no God. Knowing the limitations of observational science and historical science can help you determine what is fact and what is fiction.